Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder how you know when something happened, even if you weren't watching a clock? It is a pretty amazing skill that helps us plan our days, and even in important situations like remembering events. But how exactly do we get good at this? Especially as we grow up today, we're diving into a fascinating study that explores just that. This research team wanted to understand how our ability to remember when things happen develops from childhood all the way to adulthood. Think about it, we often need to figure out the timing of things even if we didn't check the clock. For example, you might figure out when you ate breakfast based on your morning routine. This skill is super helpful for managing our schedules. And it can even be crucial in high-stakes situations, like when someone is giving eyewitness testimony. Now, we know that kids and teenagers can make these kinds of time inferences, but we don't fully understand how precise they are or how that precision develops. So, what did our researchers do? They had children, teenagers, and young adults watch events where the exact times were never shown. The participants had to try to figure out when these events happened not by looking at a clock, but by linking together information they learned over several times they saw the same event. What they found was pretty neat. Young children could make these time estimates, but as people got older, their guesses got much more precise. This improvement was especially noticeable when the experiences the participants saw were more varied. This tells us that as our memory linking abilities develop, so does our knack for precise time guessing. Let's get a bit more scientific for a moment. This study looked at people from ages 7 all the way to 25. They played a memory game where they had to infer event times from cues that change each time they saw the event. By linking and updating this information across different experiences, they could get a better idea of when things actually happened. What they discovered is that while adults were really good at pinpointing events in time through this inference process, younger participants tended to guess times that were closer to the average. This was especially true when the time clues were more spread out or variable. So the big takeaway here is that our ability to link and update information across multiple experiences as we get older is what helps us get better and better at understanding and remembering time. You know, memories aren't like perfect video recordings, they're more like reconstructions. We fill in the gaps by remembering other events around them or by using our general knowledge about routines. For instance, if you are trying to remember when you last took medicine, you might recall doing it after breakfast. Then, you'd use your typical breakfast time, say 7:30 a.m., to estimate you took your medicine just before 8 a.m. Previous research has shown that this skill, using routines to guess event times, gets better as we grow up. But what happens when we can't rely on well-known routines? How do we figure out when something happened then? This is a really important question for everyday life, like knowing when to take your next dose of medication. And also for serious situations, like when a child is a witness to something and their testimony about timing is crucial. The researchers had a few good reasons to think children and even teens might have a tougher time with precise temporal information. First, our memory for specific details and the order of events really gets better from childhood through adolescence. Second, studies show that even when kids and teens can remember specific events, they often don't connect information across events that happened at different times as well as adults do, leading to less accurate guesses. And third, even when we ask people to guess an event's time by relating it to another event with a known time, it is not always easy for anyone, though older kids and adults are generally better at it. So, the ability to use precise time information for guessing seems to develop over a longer period. So, how did they test this? They designed a clever experiment. Participants, ranging from 7-year-olds to adults, watched sequences of events. For each event, they were shown digital clock cues both before and after the event happened. Imagine an event like reading a book before it started. The clock might show 11:02 a.m. And after it finished, it might show 12:15 p.m. This tells you the book reading event happened sometime between those two times. Now, here is the really smart part. They showed participants these same event sequences 8 times, but each time the clock cues were different. So, for the book reading event, maybe on the second time, the cues were 11:45 a.m. and 12:10 p.m. By looking at all these different sets of clock cues over the 8 repetitions, participants could gradually narrow down the exact time the event actually occurred. It is like piecing together a puzzle. The more pieces you have, the clearer the picture becomes. They set up 4 different event sequences, each with 5 events. Participants saw these sequences many times. Importantly, they never saw the exact time an event happened. Instead, they got these before and after clock cues across repeated viewings. The clock cues changed, forcing participants to link them together and update their understanding to get a more precise guess of the event's real time. This allowed the researchers to look at two things. First, their memory for the order of events, and second, how precisely they could guess the actual time of each event. They also played with the variability of the clock cues. Some sequences had clock cues that were closer together in time, while others had cues that were more spread out over a longer period. This was to see if more uncertainty or a wider range of possible times made it harder for people, especially younger ones, to guess the exact timing. We'll come back to this more variable versus less variable idea later because it is quite important. The study included 104 participants. There were 79 children and adolescents aged 7 to 17 and 25 young adults aged 18 to 25. They made sure to get a good range of ages to see how this skill developed. The experiment involved a learning phase where participants repeatedly saw the event sequences with the changing clock cues. Then came the test phase. In the test phase, participants had to sort events into their correct days or sequences. Then, for each day, they were given a timeline and had to place the 5 events from that day onto the timeline. At the time they inferred, this timeline task was key. As they dragged events onto the timeline, they could see the exact time. This let the researchers measure how close their inferred time was to the actual time. This gave them a measure of their temporal inference precision. They also looked at how well participants remembered the order of events, because if you can't even remember the order, it is hard to guess the specific time. They analyzed 2 main things. First, memory for temporal sequences. Did participants remember the order of events? They looked at both remembering the exact position of an event and remembering the links between adjacent events. If participants weren't even guessing the order of events correctly, they were excluded from the time guessing part, because you need a solid memory of the sequence to infer the timing of events within it. Second, they looked at temporal inference precision. This was all about how close their guess time was to the actual time of an event. They calculated the difference between where a participant placed an event on the timeline and the real event time. To make things fair across different days that had different overall lengths, they scaled these precision scores. Now for the exciting part, the results. When they looked at remembering the order of events, they found that this skill improved non-linearly through early adolescence. This means that while younger kids were not as good, teenagers showed bigger jumps in improvement, and then the gains started to slow down a bit as they became adults. It is like a growth spurt for memory. But here is where it gets even more interesting. When they looked at how precisely people could infer the actual times of those events, they found something different. Unlike the sequence memory, which had this nonlinear improvement, the precision of inferring event times increased linearly from childhood all the way through adulthood. This means that the ability to guess the exact time when you can't rely on routines just keeps getting steadily better as you get older. They also confirmed that participants were actually using the clock cues they saw. The clock cues were indeed strong predictors of the inferred event times, no matter the age. And interestingly, when the clock cues were more spread out, the more variable condition, people were generally less precise in their guesses. This makes sense the more uncertain the clues. The harder it is to pinpoint the exact time. Now, let's dig into that variability idea a bit more, and a concept called regression to the mean. Regression to the mean is like a bias where, if things are uncertain, we tend to guess closer to the average. Imagine you have a bunch of events that happen at different times. If you are uncertain about one specific event, you might guess it happened around the average time of all those related events. This is especially likely when there is a lot of variability in the clues. The researchers found that this regression to the mean bias was stronger in younger participants, especially in that more variable clock cue condition. This means that when the experiences were more spread out and required more mental juggling, younger kids were more likely to let their guesses drift towards the average time of similar events, rather than pinpointing the specific time. Older participants, however, were better at resisting this bias and maintained more precise guesses, even when the cues were variable. So, what does all of this mean? The study shows that even young kids as young as 7 can make pretty good guesses about when events happened, even without direct clock information. But the precision of these guesses gets significantly better as we move into adulthood. While prior research showed kids could use routines to guess times, this study looked at inferring times from scratch, just from new experiences. They found that in childhood, memory precision is lower, and this makes guesses tend to lean towards the general average of experiences, not the specific details. This happens more when repeated experiences are more varied and require piecing together more information. This is really important because it shows that children and teenagers are less likely to connect and update their time knowledge across related experiences. This leads to less precise time guesses for individual past events. Unlike guessing based on familiar routines, this study forced participants to rely on linking and updating specific clock cues they learned over time. This really highlights how our abilities to learn about time from new episodic information develop over a long period. One big reason for this prolonged development is probably our episodic memory capacity, basically how much information we can hold about our experiences. To do well in this task, people needed to keep track of several details, like those clock cues. Over time, younger kids with less memory capacity found this harder when the task got more demanding with wider ranges of time to track. The age differences really stood out. Younger children showed more of that regression to the mean bias, suggesting their memory capacity limited their precision. This also ties into how we deal with uncertainty. As we get older, we get better at resolving differences between related experiences and updating our knowledge. Younger children, on the other hand, might struggle with inconsistent information. They might either not update their knowledge when experiences are a bit different, or they might try to remember every single cue separately and then try to figure it all out later, which can lead to less accurate decisions. The fact that children showed more regression to the mean when cues were more variable supports this idea. It is also interesting that even though regression to the mean can lead to less precise guesses, it can act as an adaptive strategy when our memory capacity is lower. It is a way to make a reasonable guess when you don't have all the precise details. However, most participants, especially older ones, performed even better than just guessing based on the averages, showing that they truly were learning and updating their specific event times. What does this all mean for us in the real world? Well, the precision of our time judgments is important. Think about legal settings like forensic interviews. Accurately remembering when an event happened can be critical for establishing facts. Children who struggle to provide specific temporal information might be seen as less credible, even if they remember the content of the event. This research suggests that children's temporal inferences aren't inaccurate in principle, but their precision is limited, and this can be affected by how variable their experiences are. Of course, no study is perfect. This experiment was conducted in a very controlled lab setting. In real life, we have lots of other clues to help us guess times, like schedules or knowing what time school starts. Future research could explore how these findings apply in more complex, real-world situations. The researchers also made sure to separate memory for event order from inferring precise times. They found that while sequence memory also gets better with age, the precision of temporal inference follows a different, more linear developmental path. In summary, this study gives us a really clear picture of how our ability to link memories helps us infer when things happened. We see that while the basic ability is there in middle childhood, it gets much more precise into adulthood. Children might use adaptive strategies like sticking to averages when experiences are very varied. But as our episodic memory and ability to handle uncertainty improve, so does our precise temporal reasoning. This research not only explains the how behind differences in temporal memory development, but also highlights its importance for real-world outcomes. Thanks for joining us on RUBIN'S Mind Lab. If you found this interesting, please give this video a thumbs up. Leave a comment below with your thoughts on memory and time, and don't forget to subscribe for more fascinating science breakdowns. We'll see you next time.